When two machines talk on the internet, they don't just start shouting bits and bytes at each other. They have to agree on how to talk, when to talk, and whether they can trust each other. That's where two famous processes come in: the TCP Three-Way Handshake and the TLS Handshake with PKI. One makes communication reliable, the other makes it private. The Three-Way Handshake is part of TCP, Transmission Control Protocol, and has been around since the early 1980s. Imagine you're mailing letters back and forth, but you want to make sure the mailman knows how many letters are coming and in what order. Step 1. Your computer sends a message marked SYN, synchronize, basically saying, I want to start a conversation and here's my sequence number. Step 2. The server replies with SYN-ACK, got it, here's my own number and I acknowledge yours. Step 3. Your computer answers back with ACK, acknowledged, we're in sync. And with that, both sides know where to start counting, and that the other is listening. This clever dance was codified in RFC 793 in 1981, thanks to the early internet architects like Vint Cerf and Bob Kahn. Without it, data could easily get jumbled, lost, or duplicated. But being reliable isn't enough. You also need confidentiality, especially once the web took off in the 1990s. Enter TLS, Transport Layer Security, and its handshake built on public key cryptography. Here's how it works. 1. Your browser sends a client hello, listing the encryption methods it supports. 2. The server replies with a server hello and its digital certificate, signed by a trusted certificate authority. That certificate includes the server's public key. 3. Your browser verifies the certificate through the PKI system, a chain of trust that goes back to a root authority. If it checks out, the browser knows the server is legit. 4. Then comes the key exchange. Older versions of TLS used RSA. The browser encrypts a random session key with the server's public key. Newer versions use Diffie-Hellman variants where both sides contribute randomness to create a shared session key. 5. Finally, both sides switch to symmetric encryption. Faster, efficient, and secure. This whole process happens in a fraction of a second before any web page loads. And it's the reason you see a padlock when you visit your bank or shop online. You encounter these handshakes constantly. The TCP Three-Way Handshake happens under the hood anytime you open a website, send an email, or stream a video. The TLS Handshake kicks in every time you type https:// send a secure message, or connect to a VPN. Historically, the Three-Way Handshake solved reliability in the early internet, while the TLS Handshake solved trust and privacy once the web needed commerce and security. Diffie and Hellman's key exchange in 1976 and RSA in 1977 laid the mathematical foundation. Netscape then built SSL in the mid-90s, which evolved into TLS, today's global standard. So next time you see that padlock in your browser, remember, behind the scenes, two handshakes are working together. TCP makes sure the conversation is in order, TLS makes sure nobody's eavesdropping, and together they make the modern internet possible.